Hi, this is a video tutorial for homework 8 on the conservation of energy. And so I'm going to go through a few of the problems and give you certain hints to help you in solving the problems. Alright, so the first problem has to do with a spring with a spring constant of 80 newtons per meter. So that's question 1. We're given K is equal to 80 newtons per meter, and we asked to find how much must the spring be compressed to store 36 joules of potential energy. So since the spring, we're talking about elastic potential energy, which is equal to 36 joules, and the elastic potential energy of a spring is equal to half kx squared, where x is the amount or the distance that the spring is compressed. So in this problem, we have to solve for x, and the spring constant, the displacement x, will be equal to 2 times the elastic potential energy divided by the spring constant, and we have to take the square root of that. So putting in the numbers 36 joules and 80 newtons per meter, we find out that this displacement of compression comes to be 0.94 meters. All right. So problem 2, we are given the potential energy as a function of x, y, and z. So we told it's 9x squared plus 3xy plus 7y squared z. And we are asked to find the x, y, and z components of the force. So we know that the force as a vector is equal to minus the partial derivative of u with respect to x along the I direction, minus the partial derivative of u with respect to y along the k direction, minus the partial derivative of u with respect to x and z along the, sorry, this is the j direction, and that would be the k direction. So this minus delta u with respect to x du dx is the x component of the force, that's the y component, and that's the z component of the force. So for example, to find the x component, we have to take the partial derivative of u with respect to x. And our function u is 9x squared plus 3xy plus 7yz, so we have to differentiate this with respect to the x variable. So we have, and take the negative sign of that to get the force. So here we have minus 18x minus 3y. And since there's no x in this part of the equation, the partial derivative of 7y squared times z with respect to x is 0. So we have a 0 here, and this here gives us the x component of the force. So we have to do the same thing to find the y component and the z component by taking the partial derivatives with respect to y and z. Alright, so for problem number 3, we told that we have a novice skier who is starting from rest, and he slides down a frictionless incline of an angle of 34 degrees. And the height of this incline, so if this is y is equal to 0, is the height at this point here is equal to 102 meters. So he's going down this inclined plane, and we actually find how fast he's going when he reaches the bottom. So we'll call that V2. And so the y here will be his final position, which we'll call y2. And this is his initial position, so we'll call that y1. And since the skier is starting from rest, his initial speed, v1, should be equal to 0. So to find the speed when he reaches the bottom of the inclined plane, and since there's no friction, we'll have the conservation of mechanical energy. So the half mv1 squared plus mg y1 should be equal to half mv2 squared plus mg y2. Alright, so initially his speed is 0, so this part of the equation is 0. And the y coordinate when he gets to the bottom is 0, so this part of the equation will also be equal to 0. So we're only left with his potential energy at the top and his kinetic energy at the bottom. And so we can solve for V2, and V2 will be equal to, so the masses cancel out, the square root of 2 times g times y1, which comes up to be 44.7 meters per second.